Alright, so this is a podcast for binomial distributions, kind of a general information podcast. So the first thing about a binomial distribution is what do you need in order to use a binomial distribution, or what conditions need to be met. And this is gone over in class, but again, we want to be really sure about how we use binomial distributions. So the first thing is that you need to have a probability for success. And what that means is there has to be somewhere in the problem or situation a probability that stays fixed. So what that means is that if you do it once or twice, it's still the same probability the next time. And if you do it 100 times, it's still the same probability the next time. Compare that to a ball example, where if you're picking, from 5 red balls and 5 blue balls in a bag, and you pick 2. If I picked 1 red ball and hold on to it, and then pick another one, so if I got 1 red ball here, now the next one has a different probability of happening. Okay, so that would be a not fixed probability, and therefore not a binomial situation. So the probability needs to stay the same. Another issue with that, sometimes you'll hear of, let's say, Apple examples or things like that, or factory examples with light bulbs or calculators. Those are still binomial distributions, even though technically we're not putting it back. Once we take a light bulb and test it, we don't put it back. So in a way, the probabilities sort of change, but we have thousands upon thousands upon thousands of light bulbs, so taking 1 or 2 doesn't affect the probabilities. Next thing, the probability equation, or the binomial equation. Remember, it's n r p to the r 1 minus p to the n minus r. Now, n is your total number. Okay, so if I'm picking 200 apples, then n is 200, or 10 calculators, or 5 light bulbs, or 10 people and their test scores, whatever, n is the total number. R, number of successes. Okay, probability, we already said, is your probability for success. So think of this part as probability for success to the power of how many successes we want. This is your probability for a fail. And this is how many fails. So it makes a good contrast with this one over here, because this one, remember again, was probability for success raised to the power of how many successes. This one over here is probability of a failure raised to the power of how many failures. Alright, and then this is our binomial number, which is another way to say how many ways can that happen. So that's the equation. And the last thing we need to go over in this video, and then I'll put up another 1 or 2 samples, is how do we do this on a calculator, and how do we show what we've done on a calculator. One of the previous videos was number 3 in the book on page 623. So if you look at page 623, number 3, there's a video on that also on our website. And if we wanted to do that one with a calculator, that was our test example, so our probability of getting a question right was 70%. There were 10 questions. And, the probability of getting it right wasn't 70%, it was 20%. And he needs a 70% to pass. Okay, so that's where we said, well, he needs 7 right, 8 right, 9 right, or 10 right. Okay, so showing this on a calculator. First thing, a random variable is distributed as a binomial, and inside the parentheses we put n and p. Okay, this is the first thing you need to show on a test, because it shows you understood that this situation is a binomial experiment or distribution. Then, we know that on a calculator, we're looking for the probability that our variable is greater than or equal to 7. Okay, this is called a probability statement. We need to show that next to show we knew we were looking for 7 or bigger than 7. In this case, 7, 8, 9, or 10. Now, if you remember, we use binom CDF because it's a range, but our calculator can only go less than to the left. So what we would find on our calculator is the probability that x is less than or equal to 6, and we would take 1 minus that. So this is the first thing you need to show. Your general statement is the second thing. Your adjusted probability statement is the third thing. The next thing you show after would be the final answer. Okay, so when you're doing these with a calculator on an exam, show those 3 steps. Sometimes the third step might not be necessary. For example, if they asked us for 6 or less, we'd be fine with just 2 steps. But those are what you need to focus on showing. If you have any questions on that, make sure to come and find me. I can clarify it in person, maybe a little better than I can through a podcast. But hopefully that helps clarify, even more so, the binomial distributions.